Alright, so this is Geometry, Chapter 6, Section 3, proving that a quadrilateral is a parallelogram. Alright, so there's a lot of theorems in here. Many different ways to prove that a quadrilateral is a parallelogram. The first one they give us is 6-8. And these are essentially the inverses of some of the proofs from the previous section. Here we got theorem 6-8 that says if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So we have this parallelogram. This is theorem 6-8. So if opposite sides of a quadrilateral are parallel, then it is a, are congruent, then it is a parallelogram. Meaning, I have a quadrilateral A, B, C, and D. I know that AB is congruent to CD. I know that AD is congruent to BC. AD is opposite of BC. AB is opposite of CD. Then I know that it's a parallelogram. Okay. If these things happen, then I know that it's a parallelogram. Okay, we have theorem 6-9. And theorem 6-9 says if an angle of a quadrilateral is supplementary to both of its consecutive angles, then it is a parallelogram. Alright, so what does that mean? Well, again, parallelogram or a quadrilateral. Alright, A, B, C, D. Let's look at angle A for a second. Angle A has two consecutive angles. A is consecutive with D. A is consecutive with B. Because they both share the same side. So, if I know that A and B are supplementary, meaning they equal to 180 degrees, and I also know that A and D are supplementary, then I know that it is a quadrilateral. Alright? A has to be supplementary with B, its consecutive angle. It also has to be supplementary with D, its other consecutive angle. If I could prove that, then I know that the quadrilateral is a parallelogram. And we have 6-9. Theorem 6-9. I'm sorry, 10. And it says if both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. And if I have A, B, C, D, I know that A and C are congruent. They are opposite angles. And I know B and D are congruent. Then these guys are parallelogram. Okay. Angle A is congruent to angle C. Angle B is congruent to angle D. Then they are a parallelogram. That's theorem 610. Alright, so we have this guy here. We have a 3y minus 2 here. We have a y plus 10. We have a 4x plus 13. Then we have a 12x plus 7. Alright. If this is a parallelogram, then I should be able to get y and x. This is E or H. Okay. So remember, if this is a parallelogram, then these two guys would be supplementary. These two guys would be supplementary. So if this is a parallelogram, angle E plus angle H would be supplementary, which means that since E is 3y minus 2, and then H is y plus 10, y would equal 43 degrees. Okay, and then same thing for F and G. If F and G are supplementary, then we can find X. F is 4x plus 13. G is 12x plus 7. Combine them. 16x plus 20. Yeah. And x will equal 10 degrees. Again, E and H are consecutive angles, so it equals to 180. F and G are supplementary since we're told that we want to make it a parallelogram. They have to be supplementary, set them equal to 180, and solve. Now 611 says if the diagonals bisect each other, then the quadrilateral is a parallelogram. Alright, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. And then we have parallelogram ABCD. Then we have diagonals in here and a point E such that AE equals CE and BE equals DE. Then I know that this is a parallelogram. Whoops. BE is congruent to DE, AE is congruent to CE. If I know that, then I know it's a parallelogram. Okay, here's the proof. They bisect each other, then I have 4 pairs of vertical angles, and I can say that these 2 pairs are congruent because the side angle side is a side angle side, and then I can say that opposite sides are congruent. Then I can say there's a few ways to do it. They use alternate interior angles are parallel. They didn't say that it's a definition of parallelogram. I mean, you could do it that way too. I would just say use theorem 6, 8, but that's just me. Alright. 612. Alright. This one says if one pair, and if we've been doing 2 pairs up to this point, if one pair opposite sides of a quadrilateral are both congruent and parallel, then it's a parallelogram. So they're both congruent, and they're both parallel. Only one pair, I don't need both pairs. If that's the case, then I have a parallelogram. Okay. Got it too. Gives us two examples, and they say, do I have enough information to say this is a parallelogram? In the case of A, I don't, because I need both pairs opposite sides. I'm sorry. Yeah, both pairs opposite sides has to be congruent, or both pairs of opposite sides have to be parallel. Therefore, I don't have enough. Here, I do. I can make both pair of opposite sides parallel. So what does that look like? Yeah, I have a transversal. And this transversal, what the heck? This transversal cuts across both pairs of parallel lines. It cuts this guy and it cuts that guy. So I can say this is congruent to that. Alternating interior angles, I can say this is congruent to that. Alternating interior angles. And because of that, this diagonal cuts across not only these parallel lines, but this diagonal also cuts across these parallel lines. They cut across two parallel lines at the same time. And since it cuts across both parallel lines at the same time, then I have enough information to say that both of these guys are parallel opposite sides, and I can say that it's a parallelogram. So to prove this one, here we have our givens with the angles. Then I can say that AL, no, AL is parallel to ND. And I can say that ND is parallel to not ND, AN is parallel to LD. That's because of alternate interior angles converse. So then I have enough to say that this is a parallelogram. Opposite sides are parallel, so that's definition of a parallelogram. Three steps. Given, because they're alternate interior angles, then I can say opposite sides are parallel, alternate interior angles converse. And if opposite sides are parallel, then it's a parallelogram. Alright. 3 is silly, but we have this parallelogram, right? It's an uplift and it's rising. What's the maximum height that it can rise? And the maximum height that it can rise is 60 degrees if it goes full vertical or full 90 degrees, right? So this is 6 foot. So if it comes like at an angle, let's say like 120, right? This is 120 degrees, 6 feet, right? As it comes up and up and up, so let's say 100 degrees, rising a little bit more. This guy would go a little higher. And eventually, as it goes full 90 degrees, it will be the highest that it would be. That's sort of what it's saying. As this thing is rising up, they can't get any higher than 6 feet at full. They would say vertical, but or when it's a 90 degree between here and here. All right, look at all the proofs we've done. 1, 2, 3, 4, 5, 6 proofs in this one section. All proving things are parallelograms given a certain information. So these are all essentially the converses of the previous section. Okay. Okay, that's this section. Hope you have a great rest of your day.